When you get a background here, not green. It's like it's not showing. Okay. Good evening, good evening, good evening. Can you hear me? Can you hear me? Can you confirm if I'm audible? If you can hear my voice clearly, can you confirm, please? Can you confirm? All right, thank you. Let's just give others time to join. Just 5 minutes, just 5 minutes. Now it's a minute past 8. A minute past 8. Let's just give them 4 minutes to join. We start at 5 past. Let's just give them 4 minutes to join. Then we start at 5 past. Let's just give them time to join. Then we can start at 5 past. Now it's 1 past 8. Okay. We're just giving them time to join. Then we can start. I want us to start today with the river profile, the courses of the river. I have chosen the different questions from the past papers that we have. The one that I feel if we are to cover, then I think you'll be ready for your paper 1. So I've chosen the best questions from all the papers. I've got the 2023, 2024, 2025 NSC. Then I've got the Gauteng 2023. So I'm going to start with the Gauteng 2023, the Gauteng Prep 2023. As you can see on the screen, let me try to zoom it here like this, I think, to be more visible. We are starting in 3 minutes. Starting in 3 minutes. Good evening, good evening, good evening, guys. Good evening. How was your day? How was your day? My day was super. It's only that this flu doesn't want to leave me, but I'm surviving. I'm surviving. I'm surviving. Only 2 minutes. Only 2 minutes, then we start. 2 minutes, then we start. Please share the live, so that we can have as many people as possible joining. Share the live, share the live, share the live. Share the live, share the live. Yeah, just 1 minute, just 1 minute, then we start. Just 1 minute, it's 4 past now. Just 1 minute, then we start. Just 1 minute, then we start. Just 1 minute, then we start. Thank you so much. Don't be fast. All right, I'll try to be slow. I'll try to be slow. But you know me, I try by all means to make sure that you understand, guys. Even if I'm fast, I try by all means to make sure that you understand. Okay, guys. Otherwise, if we are to wait for the latecomers, they won't arrive on time. So, guys, the paper that I am sharing now, I'll tell you which paper it is. It is the Gauteng Preparatory Paper 2023, Paper 1. So I'm starting with question 2.4. It is the Gauteng Preparatory Paper 2023. I'm starting with question 2.4. I have chosen the question that I know if we are to cover them, then I know you'll be ready for your paper 1. So we are going to start with that one because obviously if I'm going to do paper by paper, we won't be able to cover everything. So this is the way that I'm going to work. Okay, so let's start with the diagram that we have in front of us. So guys, what we have, this is our diagram. It reads, study the diagram below that shows the fluvial courses of the river. So what I'm going to do with you guys is this. What I'm going to do with you guys, I'm going to explain in detail what makes up the upper course, the middle course, and the lower course. What are the dominant processes in as far as the upper, middle, and the lower course is concerned? The screen is glitching, is it? Let me ask my son to check a bit so that we can fix it. The screen is glitching. Okay. Let's check just a minute. Let me just fix it now. Let me fix it now. Let me just fix it just 2 minutes. Then we say the screen is glitching. Let's try to fix it now. Let's try to fix the screen, then we start. Okay, we are trying to fix it now. We are trying to fix the screen. We are trying to fix the screen. We are trying to fix the screen. Just a minute. Yeah, we are trying to fix the screen. Just a minute, guys. Just a minute. We're just trying to fix it. Okay, how's it now? How is it looking now? Is it still glitching? All right, is it fine now? Is it fine now? Is it fine now, guys? Can you confirm? Yeah, it's good now. Okay, let's start right away, guys. Let's start. It is good. Okay, sharp. Okay, it's fine. Let's start now. All right. So the first thing, guys, that I'm going to do with you, I want us to analyze the longitudinal profile of the river. You see is showing from the source to the mouth. So I'm going to explain the upper course, what is the dominant processes in the upper course, what are the fluvial features. Then I'll move on to the middle course, the dominant process, and also the fluvial features there, and also the lower course before we start with the questions. That's what I'm going to do first. So let's start with the upper course. I'm going to write the notes for the upper course here at the bottom. I'm going to write the notes for the upper course here, then the middle course I'll do it at the top, and also the lower course. Let's start with the upper course. What do we have in as far as the upper course is concerned, or I can write it here. Upper course, okay. Upper course, okay. So when it comes to the upper course, guys, some of the things that I want you to always remember is number one, it is very steep, okay? It is steep, a steep gradient, let me just say, steep gradient. Because it is steep, what we have now, our river is flowing at a very fast speed. Okay, there is a higher velocity. Okay, because of the steepness of the gradient in the upper course. So this is what causes the river to be, river is erosive. Okay, erosive. Okay, erosive, which means there's erosion that is taking place within the upper course. What is the type of erosion that takes place within the upper course? We have got what we call vertical erosion. Vertical erosion. Okay, that is the dominant type of erosion that takes place within the upper course. We have got vertical erosion. Vertical erosion, what it does is it increases the depth of the river. The depth of the river. Depth, it increases the depth of the river. That is the role that is played by our vertical erosion. It increases the depth of the river. Let me try to make sure that it increases the depth of the river. Okay, so we are saying in the upper course, a steeper gradient. As a result, the water is flowing at a very fast speed. That is your higher velocity. That's what makes it to be more erosive. And the type of erosion that is dominant there is your vertical erosion. What does vertical erosion do? It increases the depth of the river, which means it makes the river to be deep. Okay, so as a result, what we have got the V-shaped valleys. Okay, we have got the V-shaped valleys. That's what we have now. We have got the V-shaped valleys. Are you following, guys? I don't want to be fast. Someone was saying I don't have to be fast. Are you following, guys? I'm starting with the upper course. I want us to go through the upper course first. We are going to go each and every course of our longitudinal profile. Are you following, guys? Give me a thumbs up if you are following. If you understand what I'm saying just now, can you give me a thumbs up? Thumbs up, please. Thumbs up, thumbs up, thumbs up. I'm waiting for your response. Okay. So we are saying in the upper course, there's steeper gradient, okay, higher velocity, which means our water is flowing at a very fast speed. That's what makes it to be more erosive. Okay. And as a result, we have to be specific on the type of erosion that is dominant. That is your vertical or downward erosion. What does vertical erosion or downward erosion do? It increases the depth of the river. So it's more deeper there. Why? Because the river has got a lot of energy. It's eroding vertically downward. So that's why we have got the V-shaped valleys within our upper course. That's why we have got what? The V-shaped valleys. Okay, so the V-shaped valley, in general, what does it gives you? It gives you an idea of the transverse or a cross section, all right, transverse or a cross section in the upper course, in the upper course, in the upper course. It's what? It's V-shaped. This is the cross section from bank to bank. We are saying we can have a V-shaped valley, which means the transverse cross section within the upper course is V-shaped because of vertical erosion that increases the depth of the river. Okay, let's move on. The other thing that we can also talk about is there is also what we call headward erosion. Headward erosion. Okay, headward erosion. What headward erosion does is, okay, it increases the length, okay? It increases the length of the river, okay? Length of the river. That's what headward erosion does. But headward erosion now, sorry, it can be forward or backward. It can be forward or backward. That's what headward erosion can do. So it's also dominant within the upper course. That's why even when you're explaining the formation of your waterfall, we are talking about headward erosion being responsible. It says especially the backward erosion when it's retreating backward, cutting back to its source. So that's a form of headward erosion that is called what? Backward erosion. Okay. Then the other thing also that we can talk about when it comes to the upper course is the type of flow. We have got what we call the turbulent. We have got the turbulent flow. Turbulent flow. We have got the turbulent flow within our upper course. There is the turbulent flow. Obviously, is flowing on an uneven riverbed. Uneven riverbed. Okay, uneven riverbed. Okay, riverbed. Okay. That is your turbulent flow within the upper course. We have that turbulent flow within the upper course. So which means since we have talked about the uneven riverbed, we are likely to have what we call an ungraded profile. Which means when we look at the profile in the upper course, it's ungraded, okay? It's what? It's ungraded, which means now it's not smooth, it's not concave. It has got a lot of obstacles, okay? That's why now we can talk about some of the fluvial features, such as now our waterfall. Our waterfall, okay? We can talk also of the rapid. That's another. So these are nick points that you find within the upper course, which also gives you that ungraded profile. These are the obstacles that helps the upper course to maintain an ungraded profile because there is more erosion than deposition. You understand? There is no state of equilibrium between erosion and deposition. So in the upper course, there is more of erosion. That's why the profile there is ungraded. That's why if you look at how your rapid is, it's uneven as well. So we have said now, if I'm to take you back to the top end so that you can understand, okay, upper course, steeper gradient. As a result of steeper gradient, which means the water is flowing very fast, our river is flowing very fast, higher velocity. Then the higher velocity, that speed at which is flowing, is what makes the river to be more erosive. And to be specific, the type of erosion that is dominant there is what? Is your vertical erosion. Then what does vertical erosion do? It increases the depth of the river, which means it makes the river to be deep. That's basically what I'm talking about. That's why we have got the V-shaped valleys. You can talk about the gorges as well. They are deep V-shaped valleys. Okay, that's V-shaped valleys. So that V-shaped valley within the upper course. Now already I'm bringing another concept, the transverse cross section. The transverse cross section in the upper course. Cross section in the upper course. Okay, cross section in the upper course, V-shaped from bank to bank. That is your cross section, that is your transverse cross section. So it has got a V shape in the upper course. That's what I'm talking about. Then I've also mentioned that we also have another type of erosion. That is your headward erosion. Headward erosion, what comes to your mind? Obviously, if you already know a waterfall, when we're explaining how a waterfall is formed, we'll get to that. It's more dominant there. But headward erosion, what does it do? It increases the length of the river. It can be forward or backward. It can be forward or backward. Both is what? Headward erosion. Okay. Then we have also said in terms of the river discharge, we have got what we call a turbulent flow. Turbulent flow, obviously, this is on an uneven riverbed. Then it gives us, in general, an ungraded profile. That ungraded profile is supported by the fluvial features that we have, or the fluvial landforms. That is your waterfall and your rapid. That is your waterfall and your rapid. I don't know if you are following. Okay, guys, do you have any questions in as far as the upper course is concerned? Do you have any questions in as far as the upper course is concerned? Any questions? Do you have any questions in as far as the upper course is concerned? Any questions? I can even add something. Let me just add something here. There is what we call a temporary base level. I'll take it as a temporary base level. Temporary base level. Why am I saying temporary base level? Because there is the rapids, there is the waterfall. They are just obstacles that are not going to be permanent. They will be removed with time. So that's what makes them to be the permanent base level. Okay. The lowest that the river can erode. It can erode permanently or temporarily. Okay. So we are saying now there is more of temporary base level because of the presence of our waterfall and our rapid, which are neck points. So with time, they can be eroded. They are not permanent. They are temporary. Okay. Therefore, how can I get a general example about it? Turbulent level, I think, is just water that is flowing on a turbulent flow, on an uneven riverbed. On an uneven riverbed. Let me just give an example here. Just try to draw it. Let's assume this is our riverbed. It has got, I'll take this as the resistant, less resistant. I'll take this as the, all right. This is giving you more of a resistant rock. This one is more of a resistant rock. Okay. Our water is flowing like this. Okay. Okay. It's flowing like this. Okay. I'm gonna put another one here. All right. So this is the riverbed. It's uneven. Why it makes it uneven is because it is made up of resistant and non-resistant rock. So this makes up your resistant rock. This part here is made up of what? Non-resistant. That's why it is eroded. So when the water is flowing, it's flowing like this on an uneven riverbed. So this is how we end up having what you call the turbulent flow. It's flowing on an uneven riverbed. I don't know if you understand now. Yeah, uneven riverbed, okay? Or bedrocks, the same thing. Okay, thank you. All right. So let's move on now to middle course. We are moving on now to middle course. We want to move on now to middle course. We want to move on to middle course now. I want to wrap this. Okay. I want to wrap this. I don't know why it's not giving me an option to wrap. Okay. Yeah, I think I'm winning. All right. I think I'm winning. Let me try to remove this. Okay. Okay. Let me try to remove this. Yes. Yes. Okay. All right. Let's move on now to the middle course. I want us to move now to the middle course. Now I will just put it here. Middle course. Okay. Middle. Okay. Middle course. Okay. Under middle course now. So under middle course now, there is more transportation that is taking place. Transportation of material. Okay. Transportation of material or sediments. Okay. Material slash sediments. Okay. Okay. There's more transportation of material or sediments is dominant there. Okay, so what else do we have here? We have got lateral erosion. There is lateral erosion. That is the type of erosion that is dominant. Okay, but it does not mean that we can also have vertical erosion within the middle course, but it's not as dominant as lateral erosion. So lateral erosion is the side to side erosion. Okay, side erosion. All right, so what it does is it increase width of the river. Okay, it increase the width of the river. That's what it does, because it's side to side erosion. It increases the width of the river. That's what it does. So we have said, okay, we have said, let me just make sure that we, all right, sharp, enter. Okay, so we have said number one, transportation of material, of sediments. There is more lateral erosion, which is responsible for the side to side erosion, which means now it increases the width of the river, which means now our shape of the cross section or the transverse section is changing to a U-shaped, okay, U-shaped transverse section, transverse or cross section, okay, cross section. What is causing it to change to a U shape is because of lateral erosion, which is bank to bank erosion. Okay, that's why now we have got a U-shaped. Here under our upper course, we had a V-shaped because of more vertical erosion that is dominant. But here now, we are saying now it's U-shaped. And the cross-section that we have is U-shaped because of lateral erosion. That's why we have got that shape. It's U-shaped because of what? Of lateral erosion. So the middle course, the bank, that is the sides of the river, bank to bank, sides of the river. Asibengia chelete, kelet, asibengia chelet, bank to bank, to the sides of the river. Okay, to the sides of the river, that's the bank, the sides of the river. Okay, so transportation of material or sediments, lateral erosion is more dominant. Let me just write here, more dominant. Okay, is more dominant, but it does not mean that we do not have vertical erosion also in the middle course. We have it, but what is more dominant there in as far as erosion is concerned is your lateral erosion, because it erodes from bank to bank. That's basically what we are talking about. That's why we end up having what? A U-shaped transverse or cross section. And you see how many things I'm covering at the same time. So transportation of material, sediments, lateral erosion, more dominant, side-to-side erosion, it increases the width of the river. We have got U-shaped transverse cross-section. And because of this, what are we likely to have now? The features that we have, we are likely to have our meanders. Obviously, there are some of the fluvial features that you find in both the middle and the lower course. So I'm going to write meanders there. I'm also going to write an Oxford lake. Because you find it both in the middle and the lower course. So these are some of the things that you can actually find within your middle course. Are you following? Are you following? I can also add here, obviously, because what can I add? What other landform can I add under middle course? What other one can I add? Which other fluvial landform can I add under middle course? Which other one? We have said middle course, transportation of material and sediments. There's more lateral erosion that is dominant, side to side, which means it increased the width of the river. That's why it's now maintaining a U-shaped. No, rapids is in the upper course. No, Luanke, rapids is in the upper course. Rapids, you don't find them in the middle course. Waterfall is in the upper course. It's more dominant in the upper course. I can take the braided river. I can take that one. Braided stream. Okay, braided river again. Okay, braided stream. Okay, I can braided river. I can edit that one. Okay, or braided river or stream. Okay, all right. Okay, what else can I add? 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 Okay, let's just, I can also add even natural levees. I can also add natural levees. I know you can find them in both. Okay, let's end there. Say where Is this where more tributaries join? Yeah, you can also say that more tributaries joining there. Okay, more tributaries join. That is within the middle course. So are we fine with the middle course? I'm just mentioning this is just building the foundation so that we operate at the same level. I don't want you to be behind. So are we fine? This is the middle course now. We want to move towards our lower course now. We want to move towards our lower course. Okay, lower course, I'm going to write it here. Lower course, I'm going to write it, okay, here. What can we say about our lower course? Our lower course, number one, let's talk about gentle gradient, okay? Gentle gradient, okay? Gentle gradient, okay. So we are saying now here, the river has lost most of its energy. The river has lost most of its energy. So what happens now? Deposition starts. Deposition starts. Let's finish this first. Don't worry, I'll get to the meanders. Don't worry, we'll explain that. We'll explain that. So the lower course, what happens? Lower course, gentle gradient, there is more deposition that is taking place because the river has lost most of its energy because now it's gentle. It's no longer steep, which means the velocity, there is low velocity, okay, low velocity, it's been reduced now, then it starts to deposit some sediments. Obviously, remember, when a river is carrying some sediments with it, obviously some are heavy, some are light. So we are saying now there is low velocity. Of course, there is also laminar flow, okay? Laminar flow, okay? This is normally on a smooth bedrock or riverbed, okay? What else do we have? We can also talk about low velocity. There's more deposition, laminar flow. Of course, people are now talking about a more wider, okay? The shape now of our valley in the lower course is more wider, okay? Is more wider, okay? Is more wider, okay? More wider. Okay, that will be your cross section, your transverse cross section now. It's more wider. Transverse, okay. Transverse or cross section is more wider. Cross section is more wider. Okay. Then what else can we talk about in terms of the fluvial fissures or landforms? We are now talking about our floodplains. We are talking now about our floodplains. What else? Floodplains, okay, my spelling now. We are talking about our delta. We are talking about our meanders as well. You find them there. Our Oxford Lake. Oxford Lake. Okay. What else can we talk about? Our Oxford Lake. What else can we add here? We can add even the braided stream. We can also add it there because there's deposition that takes place when a braided stream is formed. Braided stream. What else can we talk about? Okay, the distributaries, you find them on the delta. I'm going to talk about the distributaries. I'll add. You find them on a delta. They are called distributaries. Why? Because when they branch out from the river, they do not rejoin. They just flow from the river to the river mouth. Tributaries, what they do, they join the main river. Distributaries, they come off from the main river and branches out to the river mouth. Okay. So we are saying now in the lower course, gentle gradient, more deposition, low velocity, laminar flow, more wider. Okay, so usually on our lower course, we are likely to have what? A graded profile at some point. A graded profile, which means now it's more concave. If you look at it, the changes that takes place over time. Okay, it's more ungraded. Obviously, you can see with the upper course, there's more erosion. And then, okay, coming of your lateral erosion, the coming in of your displacement of a temporary base level up to a point where our erosion now and deposition is coming to a state of equilibrium. You understand? So we are likely to have more of a graded profile there. Of course, it's more open, it's more wider, it's more open. So this in general is what we have in as far as our profile or the fluvial courses of the river is concerned. I've talked about the upper course, I've talked about the middle course, I've talked about the lower course. This is in general. Please, guys, do not complicate things. You remember we have got an ATP. Some of the words I know can confuse you, but I try by all means to stick within our annual teaching plan. What is expected from the syllabus? Okay, That's what I try to do, so that I don't include some of the things that are more of university level. I want to make it as simple as possible so that it suits your level. Okay, so this is basically what we have in as far as the river profiles or the courses of the river is concerned, just in general. This is what we have. This is what you should know, which means if you look at what I've said, let me just do a recap. From the upper course, I've talked about the concept of graded and graded profile. Obviously, you will see that, okay, say is trying to do something here. I've also talked about the issue of the fluvial landforms as well. You can see what we are trying to do. I've also talked about the issue of temporary base level. You can see what we are trying to do. Okay, so upper course, steep gradient, higher velocity, which means the water is flowing very fast. That's what makes it to be erosive. There is more vertical erosion, which increases the depth of the river. What else? V-shaped valleys, whatever. Transverse cross-section in the upper course. Headward erosion. Headward erosion can be, it increases the length of the river. It can be forward or backward. Okay. Backward, think about how a waterfall is formed. Obviously, when in that cutting back to the source, okay, that backward retreat, that's basically what I'm talking about. That's part of your backward headward erosion. Okay, so then what else? I talked about the type of river discharge, that is your turbulent flow in the upper course. That because it's flowing on an uneven bedrock or riverbed is the same thing. Ungraded profile. Why? Because there's more erosion than deposition. Then I've talked about the fluvial features such as your waterfall, your rapid. And I've also said that there is more dominant of a temporary base level in the upper course. Why? Because a temporary base level, at some point, it will be removed. So your nick points like your waterfall, your rapids, they form part of the temporary base level that can be removed. Okay, they are not permanent. That's not the lowest that the river can erode. With time, they can be removed. Those obstacles can actually be removed. And then I moved on to the middle course, where I say the middle course, there's more of transportation of material or sediments. Okay, please forgive my handwriting here. I see I have sediments. Okay, let me try to correct it. Sediments. Okay, all right. Then the temporary base level, much as what it does, these are obstacles that you find along the profile. Remember, we are looking at the lowest that the river can erode. It can erode to the permanent or the temporary base level. So the obstacles that you find along the profile is what makes up the temporary base level, because those things are obstacles, but they can be eroded with time, like your waterfall and your rapids. If you can think of this thing, okay, just think of an ungraded profile. It has got a lot of obstacles, but when we get to a point whereby we have got a smooth concave, the graded profile, that one has reached the permanent level. That is the lowest that the river can erode, where our rate of deposition and erosion is in equilibrium. But when it's ungraded, what you see on an ungraded profile is a temporary base level. It means with time, due to the process of erosion and the other processes that are acting within the river profile, those things can be removed. That's what makes them to be temporary base level. Obviously, we have got temporary base level when our erosion is more dominant. We have got more erosion than deposition. I don't know, Matthias, if I have answered correctly there. Thank you so much for the thumbs up. Thank you so much. So we have talked about the middle course, where we say there's lateral erosion more dominant, side-to-side erosion, increase the width, U-shaped transverse cross-section. We have meanders, we have got Oxbow Lake, we have got braided river. We also have natural levees, okay? Just in general. Lower course. Now, this is the last part now, where we have got now gentle gradient is more flat. So obviously the velocity, the river is flowing at it does not have that much energy. It has lost most of its energy. You remember the sediments that are being carried in the river, some are soluble, some are insoluble, some are heavy. As a result, now you see it's starting to slow down. Then deposition, the sediments are starting to settle down now. That's part of your deposition now that is taking place within the lower course. Then you've got laminar flow. Then you've got more wider, that is your transverse or cross section. Then you've got flat plain. These are the fluvial landform deltas, meanders, Oxbow Lake, braided stream. You've got your graded, more of your graded profile. So this is what we have. Okay. Can we move on to the questions now? With the explanation that I've given, can we move on to the questions? Give me the thumbs up. Can we move on to the question now? Okay, thank you, Mageba. Okay, okay, sure. We are moving on to the question now with this explanation. Okay. So the first question now reads, would the flow in the upper course of the river be characterized as turbulent or laminar? Guys, from the explanation that I've given, guys, I don't think anyone can get this wrong. Okay, what is the answer here? What is the answer? Let me see what you are writing. I'm seeing everyone who has written the answer there is writing the correct answer. I'm happy with what I am seeing. So it means you guys were paying attention. It means you guys were paying attention. Okay, we are saying we have got more of turbulent. Okay, we have got more of turbulent. What? Okay, is turbulent there? Okay, thank you so much. That's correct. That's correct. That's correct. That's correct. So our answer there is turbulent. Okay, sharp. Let's move on to the next question. So the next question now, it's saying, obviously, when you mention some of these guys at this level in grade 12, guys, it has something to do with application of the concept. So if you did not master the concept, then it becomes a challenge. It's more to do with application. Okay, provide evidence from the diagram to substantiate. To substantiate is simply to support. That's what it means. If you are substantiating, you are supporting. That's what it means. So to substantiate means to support. Okay, it means you want to what? To support. That's what it means. To substantiate. You want to justify. Okay, you want to justify. Okay, so provide evidence. What could be the evidence? Okay, provide evidence from the diagram to support your answer. Okay, I'm seeing the correct answer. Uneven riverbed. The riverbed is uneven, too much obstacles, rapids, uneven riverbed, steeper gradient. Okay, thank you guys. You are doing the correct stuff. You are doing the correct stuff. You are doing the correct stuff. Okay, that is correct. Yeah, okay, steeper gradient, of course, results in turbulent flow. What else? River valley is narrow and steep. River channel in the upper course is uneven. Okay, so that's what we are going to write now. We have agreed. That's what we are going to write. Okay. River channel. Okay, in the upper course. Upper course. Okay, is uneven. Okay. So I think steeper gradient, of course, all those things are relevant. All those things are relevant, but we're just trying to, okay, to be as simple as possible, okay? Then the next one, define the term cross profile. Cross profile, it is also known as the transverse profile. What is a cross profile? Remember, we said the cross profile of the upper course is V-shaped, middle course U-shaped, lower course is more wider. Okay, sharp. So what is the transverse profile? What is the transverse profile? What is the transverse profile? What we have agreed, okay, when I was explaining, remember side-to-side view of the river from bank to bank, okay? That's correct. Side view of the river from bank to bank, that's correct, okay? Cross view of the river from bank to bank, that is correct. So simply what we are saying, just to add more flesh, we are saying in the upper course is like this, V-shaped, because of vertical erosion. In the middle course is like this, okay, because of lateral erosion. In the lower course is gonna be more wider. So this is the same thing that we are talking about. So this is the same thing that we are talking about. This is your upper course, middle course, and lower course. What caused this to be different is because of the dominant processes that you have within these courses, okay? Upper course, vertical erosion. That's why it's deeper. Middle course, lateral erosion, which means now what it's doing is eroding now from bank to bank. It's increasing the width, okay? That's what it's doing. Same applies here. That will be your lateral erosion in the middle course, Okay, that's why it's U-shaped. Here there is more of your vertical, it's increasing the depth. Then here is more wider as well. There is still lateral erosion in the lower course, but it's not as dominant as deposition. It's not as dominant as deposition, okay? It's not as dominant as deposition. That's basically what we are saying. So are we fine with the transverse cross-section? Are we fine with the transverse cross-section? Give me a thumbs up if we are fine. Give me a thumbs up if we are fine. Please forgive me for my flu. Sharp. Let's move on. So, refer to the middle and lower course of the river. Guys, you are always given some tips. Refer to the middle and lower course of the river. So you don't have to find yourself talking about the upper course, because here they are telling you, okay, refer to the middle and the upper course of the river. This is what they are saying. Refer to the middle and upper course of the river. Let's look at the question now. What is it saying? It reads, okay. Can I say it shows the width depth from bank to bank? I just say that it shows the view of the river from bank to bank. I think side view of the river from bank to bank. Let's put it that way. From bank to bank, it doesn't matter whether it's deeper or it's shallow. Just to bank, that is a cross section of view. Let's put it that way. Let's put it that way. Thank you. Thank you. Okay, sharp. Refer to the middle and the lower course of the river. What do we have here? Let's check. Guys, whenever you are given an instruction, stick to that instruction. Do not create your own question. Do not create your own question. Some of you get into the exam with your own questions. You understand? That's why you end up writing the wrong answer. So this one is saying, refer to the middle and the lower course of the river. Then the question says, which of the following cross profile represents the middle and the lower course, respectively? Which of the following cross profile represents the middle and the lower course, A, B, and C? We want to choose two that represents the middle and the lower course. Which one do you think represents the middle, and which one do you think represents the lower course? A is what? A is lower course. All right, I agree. This one is lower course, okay? I agree. You guys are cooking. This is lower course. Okay. This is lower course. I agree. Then our C is what? Middle course. Our C is middle course. You know, it's nice, guys, when you're giving the correct answers. It's very nice when you're giving the correct answers. So I don't expect you to write the upper course. They said, which of the following profiles represents the middle and the lower course? Which means if you're going to write about the upper course, you are wasting your time. You're not going to get a mark for that. So you need to include only which one is the upper course and which one is the lower course. That's all. A is your lower course and B is your C is your middle course. Okay. Let's move on to the next. Are you fine with this? Are we fine with this? Can we proceed? Can we proceed? Sharp. Let's proceed. This one is now saying, describe the shape of the river valley in the middle and the lower course. We have already done this, guys. Remember when I was explaining all the courses of the river. So let's do it now. So it's saying, describe the river valley of the middle and the lower course. Let's start with one of the middle course. Middle course, how best can you describe it? Middle course, U-shaped, okay? Okay, then lower course, how best? It's more wider, eh? It's open / wider, okay? U-shape, okay? Wider, U-shaped. Obviously, Yeah, more wider U-shape. It's more or less, even if you say more wider, it's the same thing. But the effect is to still remain the same shape, but it's more wider. That's basically what we are talking about. The shape of the middle course, is it U-shape because the lateral erosion and the lower course is more open? That is correct. It's correct the way you've written it. It's very correct. It's very correct. So here, what we are trying to do here is we are trying to show, all right, middle course, how open it is. Okay, it's more wide open. Okay, it's still more or less the U shape, but it's more wide open. That is correct. That is correct. That is correct. Are we fine with B? Are we fine with B? Are we fine with B? Okay, can we move on to the next one? Let's move on to the next question. Let's move on to the next question. Sharp. Okay, this one now reads, explain how fluvial processes throughout the river course result in the formation of a valley shape of the lower course described in 2.4.4. We are now saying now, how do we end up with a wider U-shaped channel, valley, river valley? Okay, so what you have to do here is you are explaining from what happens in the upper course, middle course, until you reach the lower course. That's basically what you are supposed to do. Okay, that's what you're supposed to do. Okay, so we are saying, let me hear from you before I start writing the answer. Let me hear from you. How best can you answer this question? The question is saying, explain how fluvial processes throughout the river course result in the formation of the valley shape of the lower course described in 2.4.4. This one of the lower course. How do we get to this? What happens in the upper, in the middle, and in the lower course so that we end up with this more wider open U shape? It starts from the upper course where there's vertical erosion, from where it gets to middle course. Middle course, what we have in the middle course, there is more lateral erosion, which makes it to be wider. Okay, it's fine. No wonder you are in the right direction. Let's add, guys, let's add some more flesh. More vertical erosion in the upper course vertical erosion, headward erosion, which results in turbulent flow. Okay, let's add. What you're saying makes sense. Erosion, okay, transportation, lateral erosion. Transportation is more in the middle course. Okay, what else happens? Okay, what else? I can see that you are writing the correct information. Okay, that's correct. That's correct. Ah, Giovanni, you are cooking. You are cooking, man. We are cooking. You are cooking. I'm telling you. Giovanni is on fire today. He's on fire. Okay. It's we need to add something. I've seen what is in the upper and middle. Lateral erosion takes place and it ends up in the lower course where, okay, it's for no wonder. I think you're also doing the right thing. What else? Also, fast flow of water at the middle course. We get transportation of sediments. Sbuda. Okay, losses energy in the lower course and upper course is steep gradient. Okay, I can see, guys. I'm so impressed. I'm impressed, guys, with what you are doing here. Okay, so in short, what we are saying now is, guys, when you look at your answer is supposed to include what happens from the upper course. What you have written here is correct. In the upper course, what we have got a steep gradient. There is a steep gradient there, which means our water is moving at a faster speed, which means there's more dominance of your vertical erosion. This is what happens within the upper course. Like what you have already said there is more vertical erosion that is dominant in the upper course. Okay, but as we go down the longitudinal profile of the river, we get to the middle course. There is more transportation of sediments. Okay, so transportation of sediments and more lateral erosion, which means now there is now more lateral erosion, which changes the shape of the river valley. Okay, it's changing the shape of the river valley into a U shape. You understand? Due to lateral erosion. You understand? Even in the lower course, there is also lateral erosion, but it's not as active as deposition. So with the dominance of deposition, that's what now will make it lateral, making it a little bit wider, but deposition also settling in the lower course. All right, let me write it down. Let me write it down. Okay, let me write it down. Okay, the process of erosion. Okay, vertical in the upper course, and lateral in the middle course, creates sediments. Sediments, okay. Then I'll put a full stop here, okay. I'm continuing. Eroded sediments are transported from the upper and middle course, to the lower course, okay. The river volume and speed decreases, okay, decreases in the lower course, okay, and results in deposition, okay. Transported sediments are then deposited on the river bed in the lower course, which reduces the depth of the valley. Okay, reduces the depth of the valley. Okay, are we together? Hence, becoming more wider in the lower course. Okay. Okay, guys. Do we write the paragraph or it's in point form? Since it's saying explain, you can write it in form of a paragraph. I would say it's not a paragraph question. Of course, paragraph question usually put 8 marks. But since it's saying explain, try to write it in form of a paragraph. You can write in point as well, but as long as you are explaining. There's a difference between explaining and stating. So I would prefer you writing in form of a paragraph. That's all I can say. Because the person is saying, explain how the process throughout the river cause result in the formation of your, even if it's in point form, as long as you are explaining. Can you see? I'm going to read what I've written down. The process of erosion, vertical in the upper course and lateral in the middle course, creates sediments. Eroded sediments are transported from the upper and middle course to the lower course. The river volume and speed decreases in the lower course and results in deposition. Transported sediments are then deposited in the riverbed in the lower course, which reduce the depth of the valley, hence becoming more wider in the lower course. Okay, so guys, there is a difference between state or mention and explain. I don't know if you are getting what I'm trying to say. Even if a question says discuss, there's no way you're going to discuss in point form. There's no way you're going to explain in point form. So try to do it in form of a paragraph. You are giving an explanation. You understand? You're explaining how it happens, how it takes place. So I would prefer a paragraph than in point form. You might not get the marks. Why? Because obviously when they say each point is 2 marks, it means your point has to be well explained. So I would prefer a paragraph. I think that will help you to get more marks. Are we together, guys? Are we together, guys? Are we together? Are we together, guys? Okay. Are we together? Are we together? Thank you so much. If we are together, and I'm happy. I'm happy if we understand each other. I'm very happy if we understand. If you understand what I'm trying to say there, then it's fine. I want us now to move to the next question. The next question is about the, I would say, graded and ungraded profile. Okay, let's now go to the 2025. There's another question that is interesting as well. Are we fine with this, guys? Before we move on, I want to hear from you. Are we fine? Give me a thumbs up if you are fine. Give me a thumbs up if you are fine. Thank you so much. Let's move on to this question now. This is the next question. This is our next question. This is our next question now. Our next question. I know some of the concepts are very easy, but I'm just going for the difficult ones. That usually confuses learners. That's the one that I'm going for. Okay, some of the concepts are very easy, like a drainage basin in South Africa, your drainage density. We are going to do a question about drainage density and drainage patterns later. But we want to start with the difficult ones. Okay, so guys, this is referred to the sketches below showing 2 longitudinal profiles. Okay, it's showing what? 2 longitudinal profiles. I think after we have covered these guys, I don't think anyone is going to struggle with the longitudinal profiles. Okay, 2 longitudinal profiles. What we have? Let me just take it up. All right. So let's talk about what can you see here. Let's just talk about what we are seeing. I like this thing, guys. Yeah? Let's talk about what are we seeing. Let's talk about what are you seeing here? What are you seeing? Someone is saying graded, graded, graded and ungraded profile. Ungraded, okay, profile. That's what someone is saying. You see, what else are you seeing? Temporary base level, temporary base level, temporary base level, okay, which means there's also permanent. If you look at there is also permanent base level, permanent base level. We are going to talk about all these guys. Don't worry. We are listing now. What else? We are seeing the longitudinal profile, longitudinal profile, longitudinal profile, which means side view from source to the mouth, longitudinal profile. Someone is talking about the nick points, okay. To be specific, someone is saying waterfalls. I know waterfall is a form of nick point. Your dam as well is a man-made nick point. What else? Okay, some of the things that you are seeing. Okay, what else are you seeing? What else are you seeing here? Okay, all right. So these are the things that we are seeing now. Longitudinal profile obviously is from the source to the mouth. So we have talked about the graded and ungraded profile, temporary base level, permanent base level, longitudinal profile. Someone is saying deposition in the mouth. Okay, deposition, river mouth, of course. Deposition, river mouth. We can edit. Someone is talking about the cross section. Looking here at D and C, is talking about the transverse. Okay, cross section. Okay, that's correct. Okay, what else can we see? What else can we see? What else can we see? Okay, so these are some of the things that we are seeing, guys. Okay, these are some of the things that we are seeing. So what happens now is, I want to add something. I'm just checking something that I have here so that I can add. Okay. There's something that I want to add so that at least we can move at the same pace. So something that I want to add. So we are talking about, when you talk about the base levels of erosion, base level of erosion, let me just say here, base level of erosion, we are talking about the lowest level to which to which a river can erode, which can be temporary, temporary or permanent. Okay. Okay, temporary or permanent. Okay, what do we mean by that? Okay, what do we mean by that, guys? If you look at these two profiles, the ungraded, this one, ungraded profile, we are saying with time, these obstacles will be removed. That's what we're talking about. Okay, with time, these obstacles can be removed. That's why it's ending up giving us what we have at B, which is a smooth concave profile. So this is what makes this to be temporary, because with time, this will be removed when there is an equilibrium between our rate of erosion and deposition. So there we are going to end up having a smooth concave profile. That's basically what you're talking about. So what makes this temporary is because with time, we expect the processes, natural processes, to get rid of all these obstacles so that it maintains what we have in B, which is a smooth concave, that is a graded profile. So this is what makes these two to be temporary. But however, we have to take note that rivers cannot erode lower than the sea level. Okay, okay. It cannot erode lower than the sea level. So that's what makes it to be permanent. Someone say equilibrium is not to is equal to, no. Erosion and deposition, they are in equilibrium. That's what maintains a smooth concave profile. When the erosion and deposition are equal, that's basically what we are talking about, Brandu. That's what we are talking about. When the two, that is erosion and deposition, are in equilibrium, it means now that's what helps us to maintain a smooth concave profile. That's basically what I'm talking about. Okay. Brandu, are we together? Are we together? Can you give me a thumbs up, Brandu? So to show that we are moving at the same pace. To show that thank you so much. So we are saying here, what is happening here at the top is we don't have equilibrium between our erosion and deposition. That's why we have all these obstacles. That's what gives us a temporary base level. And we have said base level, the lowest level to which a river can erode. A river cannot erode below the sea level. That's what makes the one that is in the B to be permanent, because it can't erode below the sea level. So base level can be temporary or permanent. Temporary, it means that with time, the obstacles, the nick points will be removed with the processes that takes place. We're talking about the process that happens in as far as smoothening of the profile is concerned. So that's what results in the removal of the obstacles, which will end up giving us what we have, what it be. Are we together? That's correct measure. Erosion exceeded deposition. That's what gives us an ungraded profile. It means erosion is more than deposition. Are we together? Measure, you are correct. Measure, you are cooking. Measure, you are cooking. I'm telling you. Okay, that is correct. So now we have understood the concept of base level of erosion. The lowest level to which a river can erode. It can be temporary or permanent. That's what we are saying. Let me fix my spelling here. It can be temporary or permanent. Temporary or permanent. Why are we saying temporary? With time, the neck points will be removed. That's why we end up having this smooth concave. That's basically what we are saying. So that's why under the graded profile, we have got the permanent base level. Why? Because the river cannot erode beyond the sea level. That's what makes it to be permanent. That's why also we don't have obstacles where we have got this here, which is our graded profile. Our graded profile. That's basically what we are talking about. Are you following, guys? Are you following? Are you following? Are we together, guys, or I'm creating more heat than light? Are we together? So I've talked about, we have mentioned together that we can see the graded and ungraded profile, and we are able to identify the ungraded and graded profile. We have done that together. We have also talked about the permanent and the temporary base level. And where we have got the temporary base level, that's where we have got the nick points. You talk about your waterfall, you talk about your dam is a man-made nick point. You can understand. The river mouth, of course, there's deposition, transverse cross section. These are some of the things that we have talked about. So when it comes now to this diagram B, which is our graded profile, they are likely to ask you about the transverse, okay, profile, okay, in the upper course and also I would say in the lower course. So already when you are looking at this, you have got the questions in mind that you are likely to come across. There's no way they're not going to ask about the base level. There's no way they're not going to ask about the graded and ungraded profile. Okay, you understand? There's no way they're not going to ask about the transverse profile. Okay, someone is asking now, what is the difference between what? I'm seeing a question there. What is the difference between? sorry. Okay, I'm going to answer that question. Who wants to attempt that question before I respond? I'm just looking for something young. Who wants to attempt to answer that question before I can respond? Someone is asking, what is the difference between undergraded and overgraded? Who wants to explain before I can give the explanation? When it's overgraded, it means there is more erosion. That's what it means. River has got more energy that is required to move its water and its load, that it will be able to erode the channels. Oh, okay. Nolwande, sorry. You can explain. Sorry. Let me give you a chance. Nolwande, sorry. Okay, Nolwande, can you explain before I explain? Someone is asking the difference. No, let's give Nolwande a chance. She said she wants to explain for us. Overgraded and undergraded. Nolwande, the floor is yours. Can you explain for us? All right, let me, it looks like, all right, undergraded is, is even due to neck point and the temporary base level. Overgraded means not much erosion. Deposition is there and then, okay. All right. I'm listening to you guys. Okay. Overgraded means more motion. Not smooth erosion, and deposition is there and there. You are moving fast, say, okay, undergraded. Undergraded is in an even riverbed due to neck points. Okay. Okay. I'm seeing something. All right. If we are, how can it, I want to ask you a question. Okay. How can it be overgraded, not smooth? Not smooth, erosion and deposition is there, and then which one is more dominant? Nolwande, which one is more dominant? Because there it looks like you're confusing. It's a lot lost. Overgraded, guys. Overgraded. From the word overgraded, it's already talking about the dominance of erosion. If you can think of it, overgraded. Let me just try to write it. Overgraded. I want you to refer back to your notes as well. Overgraded. Okay, river has more energy. River has got more energy than is required. I want you to go back to your notes, guys, to move its water, and its load, and thus it will be able to erode its channel. Okay, then I'm going to write here undergraded here, undergraded. Okay, a river does not have enough energy to carry its load. Enough energy to carry its load. Deposition. To carry its load. Let me just say deposition will take place. Okay, can you check, guys? Can you check what I've written down? I also want you to refer to your notes, guys. Don't just listen to what I'm saying. Overgraded, guys, overgraded. Then you talk about deposition. Come on, guys, overgraded. That's already telling you that there's more erosion there. It's overgraded. That's already telling you that there's more erosion there. River has more energy than is required to move its water and its load. Thus, it is able to erode its channel. I want you to refer to your notes as well, guys. Okay. Done. Okay. Done. Okay. Undergrade vase does not have enough energy to carry its load. Deposition will take place. Okay. We are not talking about a graded profile. Guys, do not confuse the two. We are not talking about a graded profile. Okay. Sharp. Graded profile, of course, is correct. The balance between the rate of erosion and deposition. Okay, are we together here, guys? We want to move on to the questions. Can we move on to the questions? If you give me a thumbs up, then we move on to the questions. Is this clear now? All right. All right. The first question, what is the longitudinal profile of a river? Longitudinal profile of a river. What is the answer? Longitudinal profile. What is longitudinal? Side view of the river from the source to the mouth. Okay. Side view, that's correct, of the river from the source to the mouth. Okay, that's correct. The source, that's where the river starts, and the mouth, that's where it ends. Side view of the river from the source to the mouth, which means from here up to there. That is your longitudinal profile. So you should know the difference between a longitudinal and a transverse profile. You should know the difference between a longitudinal and a transverse profile. Okay, sharp. Then 2.3.2, which one of the sketches above shows a graded longitudinal profile? Which one shows a graded longitudinal profile? Between A and B. Which one shows a graded? Okay, that's correct, it's B. That's correct, it's B. Okay. 2.3.3. Give evidence in the sketch to support your answer in question 2.3.2. Why are you saying you are, now they are asking for you to substantiate, okay? Why are you saying it's what? No obstacles, that's correct. It's concave, that's correct. Smooth, that's correct. You guys, there's no temporary base level. There's something else that you can add. I want to add something that you didn't say. No temporary base level. Okay, which means there are no obstacles there. It's smooth. Smooth concave. Smooth what? Smooth concave. Okay. Smooth concave. My spelling now. Smooth concave. No obstacles, etc. etc. There is a permanent base level. Of course, you can talk about there is a permanent base level. Thank you so much. Okay. There's a permanent base level. Of course, in terms of flow, laminar, yeah, that's correct as well. No temperate base level, smooth concave, no obstacles. Obviously, it's also okay. The river is eroded to its permanent base level. Randu, that's correct. That's correct. You guys, yo, I'm so impressed. 2.3.4. What do we have? 2.3.4. Why is the sea indicated as the permanent base level? Oh, sorry. I've skipped 2.3.4. Sorry, guys. Classify each of the temperate base level in sketch A as either natural or man-made. In A, which one is natural? Which one is natural? On this, which one is natural? The base level here. Which one is natural between these two? Which one is natural? Which one is man-made? In A, waterfall is natural. That's correct. Dam is man-made. That's correct. You guys are cooking. That's correct. That's correct. That's correct. I've clocked it. Okay, sharp. So we are saying waterfall is natural. Okay. And then you have your dam is what? Man-made. Okay. It's man-made or human-made. Same thing. Okay. It's man-made. Okay, sharp. So we are fine there. Let's move on. Why is the sea indicated as the permanent base level? Why is the sea here indicated as the permanent base level? Why is the sea indicated as a permanent base level? Why is the sea indicated as the permanent base level? The lowest that where a river can okay, that's correct. It's indicated because it is the lowest. It is the lowest level, okay, to which a river can erode. Thank you so much, guys. Okay, it is the lowest level to which a river can erode. That's correct. Okay, it is the lowest level to which a river can erode. Thank you so much, guys. Thank you so much, guys. I'm happy. I'm happy with your responses, guys. It shows me that you know. It shows me that you know geography. You are very passionate about it, okay? Differentiate between the shapes of the crossbeam in C and D. So differentiate between the profile in C and D. C and D. What is to differentiate? You are bringing out the difference between this C and D. What is the difference? Profile C is V-shaped. Tobani, let's say it's V-shaped. That's what it is, not like B-shaped, okay? So we are saying what causes that V-shape? Okay, let's try to add more flesh. Let's not just say it's V-shaped. What causes that V-shape? It is because of vertical erosion and it is found in the upper course. Let's try to do that. It is V-shaped because of the dominance of vertical erosion and it is found in the upper course. Give as much information as possible, guys. Give as much information as possible so that you don't lose your 2 marks or your 3 marks or your 4 marks. It is V-shaped because of vertical erosion and is found in the upper course. That's basically what you're talking about. Don't just say C V-shaped. What causes to be V-shaped is because of vertical erosion, which increases the depth of the river. And it's also found in the upper course. Okay, are we fine? Then how about our D? It is because of lateral and deposition in the lower course. That's what makes it more wider. You get it? Remember, deposition is more dominant in the lower course, but it does not mean that there's no lateral erosion. So this is what also responsible for making it more wider. That is lateral erosion. So we are saying it is more wider because of lateral and deposition in the lower course. Let's stop talking about lamina, guys. Let's not talk about lamina at this point. We are supposed to comment in relation to, let's not set our own question, guys. Let's not set our own question. That's what caused some of you to lose marks. The question is, differentiate between the shapes of the cross-section C and D. We have said the other one is V-shaped, the other one is more wider, U-shaped. So, but we are adding more information to make sure that we don't lose marks. So this has nothing to do with the laminar flow. So let's not mix things. Let's not mix things. Guys, let's not mix things. It is V-shaped in the upper course because of vertical erosion. It is U-shaped and wider in the lower course because of lateral and deposition. That is straight to the point. Then you get your point marks. Don't say anything that has to do with the laminar flow. It's not relevant at this point. Okay, are we together, guys? Are we together? Okay, so we have said VC, okay, V-shaped, vertical erosion, okay. I can just add that is upper course, okay. Okay, then we have got D, wide and U-shaped, wide and U-shaped because of lateral and deposition, in the lower course. Okay. Are we together, guys? Are we together? All right. Are you following? Are you following, guys? All right. Sharp. Okay. Are we together? If we are together, please give me a thumbs up. Give me a thumbs up. Give me a thumbs up if we are together. Give me a thumbs up if we are together. Okay, sharp. Explain, of course, we have sort of answered 2.3.7 as well. If you look at it, explain the processes that give rise to the difference in the shape of, so this is also relevant here. This is also relevant here. The explanation that we have given, vertical erosion, upper course, lateral erosion, deposition, lower course, is relevant for 2.3.7. So we have given more information in 2.3.6 that also answer 2.3.7, because there they were just asking, differentiate. The other one is V-shaped, the other one is wider and U-shaped. So the explanation of vertical and upper course, now it applies more here in 2.3.7 for both. Are we together, guys? Are we together? That explanation, it applies now to what? To our 2.3.7, which means we have indirectly answered that. Can you see what we have done, guys? Give me a thumbs up if you understand what I'm saying. We have already answered was the explanations of vertical erosion for C and lateral and deposition in the lower course is answering what is required in 2.3.7, which means we are done with that part. Are we together, guys? Thank you. Can we move on to the next one? We are still on 2025. We want to move on to 2.3.4. 2.4. Are we together? I think we are together here. All right. We are here now. Okay. This is the next question now that we have. Guys, I've chosen the question that I know that after, if we are going to cover them, I think you'll be fine. So what we have here, refer to the photographs A and B below showing meanders. Okay, let's talk about this, guys. Let's talk about this. Let's talk about this. I enjoy analyzing the diagrams. Okay, what can we say about, all right, what can you see here? What can you see? I want to ask you guys, what can you see? Can you tell me what you are seeing here? Meander, that's correct. Nolwande, that's correct. There's a meander there, I can see it. What else can you see? Meander, that's correct. Meander, okay. What else can you see? Are you not seeing a flat plane? Because on the sides, you can see now it looks like it's a floodplain where farming is taking place. You are also seeing the inner bank, inner and outer bank of the river, which is more like the cross section. Is there any braided river here, guys? Is there any braided river? This is your meander, guys. This is your meander here. Okay. So we are seeing a meander. What else? What else? What else? Let's see. To incise is simply to cut deep. What else? Slip off, cut off slope, undercut slope. Of course. So we are seeing a meander. Okay. Cross section of a meander. Cross section of a meander. We are likely to be asked a question about the cross section of a meander. I can also talk about the floodplain. Okay, where am I getting it? Check here, guys. This side, you can see farming can take place on this. That's part of your floodplain. We can also talk about, they are common, where we have got meander, they are also common. The raised banks. We can also talk about natural levees. I think we can. Natural levees, although they are not that visible, but we can talk about them because obviously you can see with the raised bank. Obviously, if we have got a floodplain, it means the natural levees, what they do, they also control flooding so that farming that is happening on the floodplain here, they won't be affected, the crops won't be affected by floods from the river. So let's talk about the levees as well. Natural levees, I think we can talk about them. There's floodplain, you can see there's farming, of course, taking place, which means there's floodplain. I think those are the dominant things. Okay, in which course do we find our meander? We have said it's in the middle and lower course, isn't it? Middle and lower course. That's where it's more dominant, middle and lower course. Okay, let's say middle and lower course, that's where it's more dominant. Okay, anything else that we can add? Anything else that you want to add? Anything else that you want to add? Obviously, where we have got a meander, there is dominance of lateral erosion. There is dominance of what? Lateral erosion. There is more lateral erosion where you have got your meander. There is more lateral erosion. Because lateral erosion is responsible for the formation of our meanders, okay? There's more lateral erosion there. What else? We have said meander, middle and lower course, lateral erosion, cross-section of the meander, floodplain, natural levees. So these are some of the things that we are saying we can see. These are some of the things that we are saying we can see. All right. Let's look here and see what is happening. Okay? So here, it means we are likely to be asked about the cross-section of a meander. That's why we have got these two diagrams. They are going to ask you which one is the correct cross-section of the meander. So between the two, which one do you think is the correct cross-section of a meander? Between this and this, which one do you think is the correct cross-section of the meander? Which one between the two do you think is the correct cross-section of the meander? All right, let's do it like this. Are they named? Okay. This is your, let's name this one as A. I don't see any letter here. Okay, A. Let's name this one as A. And this one, sorry, as B. So between A and B, which one is the correct cross-section of the meander? Which one is the correct cross-section of the meander? Come on, guys. Come on, guys. Come on, guys. Stop guessing. Stop guessing. Remember, I can go for A. I think A is correct. B is wrong. Remember, guys, this one, C, okay, is your, C is your inner bank. Yeah, C is your inner bank, okay, is your inner bank, where there is more what? Deposition, which means it gives you a slip off slope. Then at D, it's more deeper. Here, what do we have? that is your outer bank, where you have got more erosion, and you have an undercut slope. You have got an undercut slope. You have got an undercut slope. That's basically what we have. That's basically what we have here. So you can see here it's more deeper here because of erosion. Erosion is what deepens this side, which is our outer bank. Check here the way in which our meander, sorry. So this becomes more. That is your at D. That is your outer bank. Here is your inner bank. Okay. Are we following, guys? Are we together? Are we together? Can we move on to 2.4.1? Let's move on to 2.4.1. Here we're just analyzing the diagram. Let's see what the question is asking us. Okay. Meanders are more likely to form in the which course from the options given? Which course from the options given? What is the correct answer? That is your lower, ne? Lower course, ne? That is your lower course. Okay. Please, when you are given these two options, don't write middle course. Choose from the options that are given. I know middle course is correct, but choose from the options that are given. Do not create your own question. Sharp. Then next one, it says 2.4.2, account for the gentle gradient of the inner bank at C in the photograph A. See the way I was explaining inner bank, you understand? What causes the gentle gradient of the inner bank at C in photograph A here? What causes, okay, what is happening? Thank you so much, guys. Deposition, okay? Deposition is more dominant, okay? More dominant, okay? In the lower course, okay? In the lower course, okay? Deposition is more dominant, okay? I'm adding more information, but if you just say deposition is more dominant in the lower course, there you get your 2 marks there. Then what else? Refer to the photograph B and cross-section EF. Okay, so it's saying now refer to the photograph B and cross-section EF. Let's go there. It's saying refer here to this, okay? Photograph EF, okay? That's what it's saying, photograph EF, okay? This is what you are referring to. Let's get to the question and see what it is saying. No, sorry. I've taken it up. All right. How does the process of river rejuvenation lead to the formation of incised meanders? Okay, how does the process of river rejuvenation lead to the formation of incised meanders? Okay, 2.4.3. Let's start by defining what river rejuvenation is. Let's start by defining what river rejuvenation is. What is river rejuvenation? What is river rejuvenation? Let's start by defining river rejuvenation. What is river rejuvenation? Okay, so there's something missing in your definition. When a river gets more energy, there's something I want you to be specific. When a river regains energy and starts to erode vertically, that is the full definition of your river rejuvenation. When a river becomes more energetic and it starts to erode vertically. So don't just say when a river regains energy and live there and start to erode. How does it erode? Is it laterally or headwardly? You understand? So be specific. When a river regains energy and starts to erode vertically, that is correct. When a river regains energy and starts to erode vertically, that is your river rejuvenation. Okay. Okay. No, there is more of vertical erosion when we talk about river rejuvenation, not lateral. Please. When a river regains energy and starts to erode vertically, let's not talk about lateral erosion at this point. Remember, The question is saying river rejuvenation lead to the formation of incised meanders. How does river rejuvenation lead to the formation of incised meanders? What is, okay, let me put it this way. Let me put it this way. Okay. To incise is to cut deep. To incise is to cut deep. So we are saying now, when a river regains energy, it starts to erode vertically, resulting in incised meanders. That's what is happening. At this point, I understand, guys. I understand the dominance of lateral erosion in your meanders, but with river rejuvenation, there is dominance of vertical erosion. I want you to clock that. Okay, guys, with river rejuvenation, there is dominance of vertical erosion. At this point, can we not talk about lateral? I know there's dominance when meanders are formed, but we are asking, how do we end up with an incised meander? That is the question. So at this point, we are not, lateral erosion is off the question, okay? River rejuvenation, a river regains its energy and it starts to erode vertically. So we want to see how the regaining of the energy of the river and vertical erosion results in incised meanders. That's why here I have said to incise is to cut deep. So when a river regains energy, it starts to erode vertically, resulting in incised meanders. That's basically, that is straight into the point. Vertical erosion is dominant. Remember, that's why they are talking about river rejuvenation. River rejuvenation, a river regains its energy and it starts to erode vertically. I understand that lateral erosion is responsible for the formation of meanders, but at this point, we are saying, how does the process of river rejuvenation lead to the formation of incised meanders? I have started by saying to incise is to cut deep. How is the river rejuvenation cutting deep the meander to result in incised meanders? We are saying when a river regains its energy, it starts to erode vertically, resulting in incised meanders. So that is the explanation of river rejuvenation and how it results in what we call an incised meander. Are you following? You get 4 marks because number one, we have talked about the river regaining energy, and what will happen is starts to erode vertically, resulting in your incised meanders. You get your 4 marks. It's guaranteed. So the only thing that results in the formation of incised meander is vertical erosion. River has got more energy, it starts to erode vertically. That's how it incised. That's how it cut deep. You get your 4 marks, guys. You get your 4 marks. It's straight into the point. When a river regains energy, that's a point on its own. It starts to erode vertically, resulting in incised meanders. You get your 4 marks. Are we together, guys? Are we together? Thumbs up if you understand this question. Thumbs up. Please, at this, if you have a question like this that is talking about river rejuvenation, forget about your lateral. The only thing that is relevant when it comes to river rejuvenation is a river regaining energy and starting to erode vertically. Those are the two relevant things. It's an indirect way of asking you what is river rejuvenation. So whenever we are talking about river rejuvenation, even if you know that lateral erosion is responsible for the formation of your meander, don't mention it. River erosion, river regains energy and starts to erode vertically. So when it's eroding vertically, that's how it cuts deep and incise to form incised meanders. Okay, lateral erosion, this is the side-to-side erosion that increase the width of the river. Like for example, let's say This is our river. So we have got lateral. What it does, it erodes from bank to bank. That is your lateral here. Okay. So that is your lateral here, side to side erosion. May you please explain how the river rejuvenation is going to occur in photograph B? Okay. This is what I've just said, Brandu. Okay. This is what I've said. Let me go back. Okay. We are saying here in B, what is happening is the river regains energy. After it has regained energy, there's going to be more vertical erosion. That vertical erosion is going to cut deep, which result in the formation of what? Incised meanders. I've written it down here, Brandu. I've written it down here. Let me show you. I think I've written it where? Here. Incised is to cut deep. When a river regains its energy, it starts to erode vertically, resulting in incised meanders. Okay. Brandu, are you fine now? Are you fine now? When a river regains its energy, it starts to, it's just to cut deep. That's how incise me. To incise, boys and girls, is to cut deep. Incise, cut deep. The vertical erosion is what forms the incised meander. So when a river regains energy, it starts to erode vertically. That's how an incised meander is formed. The meander already exists, but now the river has regained its energy, and it starts to what? To erode vertically. That's how the meander is incised. It's deepened through vertical erosion. Is it clear now? Is it clear now? Thank you so much. If it's clear, thank you so much. Thank you so much if it's clear. Can we move on to 2.4.4? Let's go 2.4.4 now. I want us to do 2.4.4. Okay. 2.4.4. 2.4.4. Let me wrap this. All right. 2.4.4 now is saying refer to photograph A in a paragraph of approximately 8 lines. Explain how an Oxford lake is formed. Okay. How is an Oxford lake formed? How? Explain formation of an Oxford lake. All right. Who wants to try? Who wants to try before I explain? Who wants to try and give us? It starts with the meander loop. Over time, it gets closer to each other and end up meeting. Okay. Continuously undercutting on the outer bank. I'm going to type something, but I want you to write what you think first, then I can write the final answer. Forming a horse-like shoe shape, which is Oxford lake. Yeah, you guys, you know what you are talking about. Due to the dominance of lateral erosion on the outer bank. So let's put it like this. Lateral erosion result in the formation of the meander. You understand? So at the outer bank, of course, there's erosion, okay? The meander neck becomes narrower. That's correct, that's correct. Okay, I didn't read it nicely. It's fine. The Oxford lake forms from a meander loop that's cut off from the mainstream. Let me put it this one. Remember, you're supposed to get 8 marks. So try to expand your explanation so that you'll be able to get all the 8 marks. Remember, it's important. This is a 15-mark question. Yeah, it's correct. There's nothing wrong there. It's correct. So remember, guys, this is 8 marks. So try to give as much information as possible. That's what I'm trying to say. Try to explain the stages. Okay, continuous undercutting result in the loop, getting tighter. That's correct. What I'm seeing, I like what I'm seeing. Can I type something? Whilst you're writing, let me type something. Okay. Continuous, let me just type something. Continuous, continuous. Yeah, my spelling here. Continuous, okay. Continuous lateral erosion. Continuous lateral erosion takes place. Okay. And then outer bank and cut slope, undercut slope, deposition on the inner bank on the inner bank, that slip off slope, then what else happened? River floods and cuts through them, meander neck, okay, meander loop is separated from the mainstream, okay, resulting in the formation of an ox black. Okay, is this clear, guys? What we are saying in other ways is we have got something like this. Okay, we have something like this. Okay. So this is our river. It's flowing in this direction. So when the river is flowing, here is more of your outer bank here on this side, which means erosion is taking place here. Erosion is taking place here, which narrows. So this erosion, what it does is it narrows the neck of the meander. It keeps on narrowing the neck of the meander. We are going to end up with something like this now. Okay. We're going to end up with something like this now. Okay. Please forgive my drawings. So it means our river is now going to flow direct now. It's bypassing. The deposition in the inner bank is what has managed to seal this now. The neck of the meander has been cut off now, so we have got our river flowing now. That's basically what we are talking about. So we are saying, in short, continuous lateral erosion takes place on the outer bank and undercut slope. This is where it's taking place here on the outer bank, okay? Deposition on the inner bank, obviously on the inner bank, that's where deposition is taking place. That is what is going to seal the Oxbow Lake. River floods and cuts through the meander neck, which means when it's in flood now, it has got more power. So that's what causes now to bypass or to continue narrowing the neck of the meander up to the point whereby now it has been cut off from the mainstream, separated from the mainstream now. Deposition sealed this, but now it's flowing direct. Then we have got here as our Oxbow Lake. That's what we are going to have as our Oxbow Lake. So this one becomes our Oxbow Lake. This one becomes our Oxbow Lake now. Okay. Are we together, guys? Are we together? Is it clear now? All your explanations are correct. All your explanations are correct. I was reading them, they are correct. I don't see anything wrong. But here I'm just trying to make sure that we have got something conclusive to say, okay, this is what we want, or this is how it's supposed to be. Are we together, guys? Give me a thumbs up if you understand. Give me a thumbs up. Give me a thumbs up if we are together. Give me a thumbs up. Okay, sharp. I want us now to move on to, let me see. 2023, can you please remind us also about the meander scar? Okay, knock off time. All right, guys, what is a meander scar? Let's hear from you guys. What is your own understanding of a meander scar? What is your own understanding of a meander scar? Let me hear from you. What is your own understanding of a meander scar? Someone is saying, can you please? Thank you so much, Tongwana. When the meander lake biam, thank you. That is straight into the point. When the streams is dried out. Thank you so much, guys. Thank you for coming to the rescue. I'm not going to add or subtract. I'm not going to add or subtract. I think that one is straight into the point. That is straight into the point. Okay, sharp. Let's do this. Let's do this now. Let's do this now. 2.3. I think Brandu, you have been answered there. I'm not going to add or subtract. It's straight into the point as it is. Okay, let's do this now. 2.3. What can you see here? Let's do this now. What can you see? Let's do this, guys. Drainage patterns, drainage patterns. Let's do this now. Let's do this. Let's do this. What can you see, guys? I want you to, oh, you want to do a screenshot? All right, let me go back. Where's that one? Okay. You can take the screenshot there. Okay. Are you done? Are you done? Are you done there? I want us to go to the next one. I want us to go to the next one. If you are done, please just tell me no. Thank you. Let's go back to this one now. Okay. Sharp. Guys, what can you see here? I know it's drainage patterns. It's drainage patterns. But I want you to name them. These are drainage patterns. I know they are drainage patterns. Drainage patterns. Okay. Can we name them? Which drainage pattern is A and which one is B? Yeah, I like what I'm seeing there. So this one, I agree with you guys. A is rectangular. Is rectangular. Then B is what? Dendritic. Dendritic. Okay. Dendritic. Okay. I agree with you there. It's dendritic. I want to okay. So what we are going to do, we are just going to go through. We are going to go through the questions now. I'm just checking my information here so that at least we move at the same pace. Okay. Let's now start now. So now that we know we are able to identify this, of course, we are going to go through the question to make our life easier. So let's start now so that we don't waste time. Identify the drainage patterns A and B. We have done that already. We have said A is what? Is rectangular. Okay. Is rectangular. Okay. Then we have also said that our B is dendritic. Okay. Dendritic. Okay. That's fine. Let's move on. When it comes now, guys, to before we talk about this, when it comes now to the drainage pattern, guys, They are certain landscapes where you expect to find them. They are not common. What I'm trying to say is, they for each and landscape, each and every drainage pattern, there is supposed to be the explanation behind the underlying rock where it is common. Are you together? Like for example, if you are to talk more of a drainage pattern that you find on steeper slopes, it's likely to be your what? Your parallel. You understand? That's where it is common. If you are to talk about a drainage pattern that is found in rocks of uniform resistance, that is your dendritic. If you are to talk about maybe of a drainage pattern that is more common in well-jointed or areas that you have experienced faulting, that is more of your rectangular. You understand? So you find that this is what differentiates the drainage patterns. The underlying rock is what differentiates. That's why they've got different shapes. You understand? It is because they require certain conditions in terms of the underlying rock. That's what differentiates them. That's what, even when you look at this, you will see that your dendritic is resembling the branches of a tree. There is a reason behind that for it to maintain this shape. If you look at a rectangular where the tributaries are joining the main stream at right angles, there is a reason behind that. You understand? It has something to do with the underlying rock. That's basically what I want to say. Okay, so let's do the question now. State the underlying rock structure and the rock type on which the drainage pattern A developed. Okay, so we are saying now, for our A is, we have said A is rectangular. Eh? Let's start with A. 2.3.2 now. Are we together, guys? We are on 2.3.2 now. 2.3.2, we have said A is what? Rectangular. Okay, what is the underlying rock? Rectangular. The rock structure actually. So we are looking at jointed rocks, okay, or areas where faulting is taking place, or we are talking about horizontally layered rocks, or we are talking about what? Horizontally layered rocks. Horizontally layered rocks, okay. Layered rocks, okay. That is the underlying rocks. So when you talk about the rock type now, rock type, that's something else. Rock type, rock type, where is it common? We are talking about igneous, okay? We can talk about what? Igneous or sedimentary. 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 Are you following? There's no trellis here. There's no trellis. Trellis has got two main streams that are parallel. So this one is rectangular. There's no trellis, Mageba. There's no trellis. We only have rectangular and dendritic. There's no trellis here. There is no trellis. This is your rectangular. This is your dendritic. Your trellis is like this. It can have two streams that are mainstream parallel to each other. Of course, let's say they are flowing towards this direction. They are flowing towards this direction. Then you can have your tributaries joining at 90 degrees. Okay, joining at 90 degrees. You understand? That is your trellis. So this one becomes your trellis. This one, that is your trellis. That is your trellis. So what we have here is the rectangular and dendritic. Mageba, are we together? Let's correct that. Let's correct that. I don't want to give you poison. Mageba, can you confirm if you understand now? This is rectangular. This is dendritic. We don't have trellis here between the two. This is your trellis here. Thank you. Thank you so much. Let's move on. Okay. So are you fine with 2.3.2? So rectangular jointed rocks where faulting has taken place, horizontal layered rock. That is the rock structure. Then the rock type now is igneous or sedimentary. Are we fine? Are we fine? Sharp. I'm assuming that you are fine. Let's move on to 2.3.3. Explain how the underlying rock kindly repeat number 2. Okay, number 2 is saying State the underlying rock structure and the rock type. So your question is in two parts. It wants the underlying rock structure and the rock type. Your question, Nolwande, is in two parts: underlying rock structure and the rock type. The underlying rock structure, that's where we said it is common in well-jointed rocks or where faulting has taken place, or in horizontally layered rock. That is the underlying rock type, where it is common, where it is formed. The rock type now is your igneous and sedimentary rock. That's how you respond to this question. Underlying rock structure, that is your well-jointed, where faulting has taken place, or horizontal layered rock. That is your underlying rock structure. Then the rock type there is igneous or sedimentary. Are you following? Give me a thumbs up if you understand. If you are fine now. Are we together, Nolwande? Thank you. Then number 2.3.3, explain how the underlying rock structure influence. How does it influence now? Why are we going to end up with those tributaries that join the mainstream at 90 degrees? Why do we end up with this mainstream that bend at 90 degrees? How do we come to that shape now? That's what we are trying to answer now. Explain how the underlying rock influence the drainage pattern. How do we come to this shape that we have in as far as our rectangular is concerned? How does the underlying rock give us this shape that we have here? That's basically what we're talking about. How the underlying rock structure influence the drainage pattern. That is your 2.3.3. So we are now saying river flows in joints that have 90 degrees bends. We are now answering the question now. What else can we include there? That is a 2.3. Tributaries join the main stream at 90 degrees angle. Are you following? Exactly. Is the same thing that you're talking about, but we want to bring about why does it have these 90 degrees that river flows in joints that have 90 degrees bends. Is correct. We are saying the same thing, but in a different ways. It's because of the joints that it's able to have that 90 degrees bends. Tributary join the mainstream at 90 degrees angle. That's how the underlying rock structure influences the drainage pattern. Are we together on 2.3.3? Are we together, guys? Are we together? Are we together, guys? Can you give me a thumbs up if you understand? Are we together? 2.3.3. Can we move on to 2.4.4? Can we move to 2.4.4? Are we together, guys? Sharp. So the next question now is saying the drainage density at B. So before we answer the question 2.3.4, let's talk about drainage density in general. Let's talk about drainage density in general. What is drainage density? Let's talk about drainage density before we answer, because I don't want to assume that you know what it is. What is drainage density? Let's talk about drainage density. What is it? What is drainage density? Let's talk about, before we answer, let's not rush. 2.3.4, let's explore. What is drainage density? We want to know what is drainage density, what causes higher drainage density and lower drainage density. Let's talk about that first before we respond to this question. Okay, total length of streams, total length of streams per unit area. That is your drainage density, the total length of streams per unit area. That's the definition of your drainage density. That's your definition of your drainage density, the total length of streams per unit area. The ratio between the total length of streams and the drainage basin. Yeah, that's correct as well. Super boy, Billy, that's correct. It's also correct. You are right. Total length of streams per unit area. You are right, guys. I just tried to simplify, guys. I didn't want to use a lot of words. I want to give you something that you won't forget. Total length of streams per unit area. That's the simplest definition. I know there's a lot of ways that you can add them. You can add in a drainage basin. Is the same thing. Total length of streams per unit area. So we have got what we call higher drainage density. Higher drainage density. Okay. So what usually happens when we have got higher drainage density? We end up having more streams, more streams flowing. Okay. If we have got more streams that are flowing, that is your higher drainage density. What causes higher drainage density? If we want to find out what causes higher drainage, we should have more surface runoff, okay, and less infiltration. Less infiltration. Okay, so we are saying higher drainage density, more streams flowing. That's what results in higher drainage density. In order for us to have what we call higher drainage density, we should have more surface runoff and less infiltration. So let's talk about what conditions favors more surface runoff. Chingwani have already said, we have said now, number one, we have said we need to have what? More rainfall. Okay, it means if we are going to have more rainfall, we are likely to have more streams flowing. That's basically what we are saying. So the more rainfall that we have, the more precipitation, the more streams that are going to start flowing, because more rainfall, more surface runoff, then more streams. What else causes higher drainage density? What else causes higher drainage rainfall? We can talk about the steep slope. Okay, steep slope, okay, steep slope. So we are saying now, when it rains, steep slope does not allow water to settle. So as soon as it rains, it starts to flow, which means now we have got more streams are supplied with water from surface runoff. We can also talk about less vegetation. Less vegetation. How does less vegetation favors higher drainage density? Remember, when we receive rainfall, it means now the soil pore spaces are compacted. So as soon as we receive heavy rainfall and there is no vegetation, the soil pores are compacted. Then we have got more surface runoff, which means it's also aid to more streams flowing. That's what happens there. So less vegetation causes higher drainage density. What else? Impermeable rocks. Impermeable rocks. Okay, what happens with impermeable rocks? They do not allow water to pass through them. So it means as soon as it rains, we have got more surface runoff where the surface is impermeable, where we have got impermeable rocks. So they do not allow infiltration. They increase more surface runoff. So this adds to the amount of surface runoff which supplies more water to the streams, which means we have got more additional streams flowing. So our impermeable rocks also result in more surface runoff, high drainage density. Okay, so we can also say, what else can we talk about? What else can we talk about? I want to hear from you. What else can we talk about? What else to? Wait a bit. Let's not talk about formation of gullies. Less porosity, yes. Please, let's not talk about that. Less porosity. Okay. Which means if a rock is not porous, it doesn't allow water to pass through it as well. If it's not porous, which less porosity, it means it's non-porous. So it doesn't allow water to pass through it. So it means it enables more surface runoff. Then hence we have got what? Porosity. We are looking at an aspect of the rock, of course, allowing water to pass through it. Porosity and permeability is more or less the same thing. Porous from the word porous. Porosity is coming from the word porous. So porosity and permeability is more or less the same thing. Okay. Are we together? Nolwande, are we together now? All right. Let's talk about, more like that. It allows water to pass through it, okay? Let's talk about now less low Low drainage density. Let's talk about low drainage density. Low drainage density. Low drainage density. All right. Which means we have got less streams sorry, flowing. So here we have got more infiltration, more infiltration, more infiltration, and less surface runoff. Less surface runoff. Okay, are you following, guys? So what explains? Okay, we haven't started answering the question, guys. We are talking about drainage density. We are still on 2.3.4, but we want to explain the concept of drainage density. We haven't started answering. We are still on 2.4. So what we are doing, we are explaining the concept of drainage density. Starboy, we are only explaining the concept of drainage density. We haven't started answering any question. So we are saying now for low drainage density, we are supposed to have what? We are talking about low rainfall. It means low rainfall, less streams flowing. We are talking about gentle slope, okay? A gentle slope, what it does is enables water to collect, which means obviously result in more infiltration. We are talking about more vegetation, more vegetation. What more vegetation does is it actually creates a situation whereby when it rains, the rain is not going to close up the pore spaces because the leaves, what it does, it intercepts the raindrops so that before it gets to the ground now, it doesn't have that much impact that can close the pore spaces, which means that's how dense vegetation can result in more infiltration. What else can we talk about? We can talk about porous rock, okay? Let's talk about permeable, okay? Permeable surfaces or rocks, okay? So it's the opposite of what causes higher drainage density. So are we fine now, guys? With this, are we fine? Do we all understand the concept of drainage density now? Are we all fine? Give me a thumbs up if you understand so that at least we can start answering the question. Thank you so much. I think we all understand now. So guys, that's why I don't want to rush you. I just don't want to give you answers. I want you to understand the concept. The moment you understand the concept, then it's very easy to apply it. Okay, so 2.3.4. Permeable. A permeable rock is not hard. It allows water to pass through it. If it's impermeable results in higher drainage density, but permeable results in lower drainage density. Nolwande. So we can't say permeable hard rock. It's likely to be soft. Okay, permeable, porous. Okay. Are we together, Nolwande? Before I start with 2.3.4, can you respond? Can you respond? Can you respond? Can you respond? Nolwande, I'm waiting for your response. Where exactly are you lost? Permeable. It allows water to pass through it, same as porous. But if it is impermeable, which means it encourages more surface runoff. So when you're talking about permeable, it means now it encourages more infiltration. That's basically what you're talking about. That's why we said permeable rocks. Are we together now, Lolwande? Impermeable does not allow water to pass through. It's not porous, it's non-porous. It results in higher drainage density. If it's permeable, it encourages more infiltration than surface runoff. That's why it results in low drainage density. Nolwande, are we together now? Is it clear? Thank you. So let's do 2.3.4. The drainage density at B. Drainage density at B. If you compare A and B, which one has got more streams flowing? Which one has got more streams flowing between A and B? Which one has got more streams flowing? It's B, which means B has got what? Higher drainage density. That's simply what it means. So the drainage density at B is what? Is higher. Are we together? So the answer here now is what? Is higher. The answer here, okay, the answer here, let me write it here, is what? Is higher. That is the answer there. It's high. The drainage density as B is higher drainage density. This is lower drainage density. Are we together? Sharp. Give me a thumbs up if you understand now. Give me a thumbs up. Are we together, guys? All right. I want to explain the concept of stream order before we answer 2.3.5. I want to explain the concept of stream order. Okay. So when it comes to stream order, I'm going to draw something here. A simplified diagram. I'm going to draw a simplified diagram here. Okay. All right. All right. I'm going to draw a simple diagram. Okay. 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 I'm going to draw a simple diagram. Okay. So here's what we have, guys. I want you to pay attention now. This is our, okay, more of our drainage basin. So we are saying now here, when you're talking about the stream order, here where it starts, we have got 1. It starts at order 1. Like let me remove this and try to put it on the other side. It's 1 there. Then here as well is what? It's 1. 1. 1 and 1 gives us a second order. That is 2 here. That is order 1 and 1. There is 2. Then here as well is what? Okay, I want to put it here. It's 1. Then there is 1 here, 1 here, which means 1 and 1. What does it give us? Here we're going to get what? Stream order 2. Okay. Then here what we have? We have got 1. Then here as well we have got what? 1. So this 1 and 1, it gives us here 2. It gives us 2. Okay. Here we have got 1 and 1 here at the bottom, which means it gives us 2 here. It gives us 2 here. Okay. So 2 and 2 gives us 3 here. Gives us 3 here. So 2 and 2, what does it give us here? It gives us 3. Then our 1 here. Okay. And 1 here. It gives us what? 2 here. Then we have got this 2 is already in this 2. So which means here, this 2 and, okay, 2 and 2, where they meet here, they are going to give us what? 3. They are going to give us 3 here. Okay. So they are going to give us 3. Because 2 and 3 here, they are going to give us 3 here. Okay, 3 and 3 here, they are going to give us the 4th order. I don't know if you understand the way I was doing the stream order. Do you understand, guys? So the first 1, 1, 1, 2. 1 or stream order 1 and 1, 2. Stream order 1 and 1, it gives us 2. Now we have got these 2 and these 2 that is coming from this side. Obviously, they're going to give us 3. We have got 2 and 3. It still remains 3 here. Here we have got 1 and 1, 2. 2 and 2. That's why we have got these 3 here. 1 and 1, it gives us 2. 1 and 1, it gives us 2. 2 and 2, it gives us 3. 3 and 3, which means here is 4th order. If I'm going to say what is the stream order at X here, let me say at X here. So it will be 4th order. Are we together, guys? Are we together with the stream order? So in short, we can say the higher, okay, let me just say the higher the stream order, the higher the drainage density. Drainage density. That's all we can say in short. The relationship between your stream order and drainage density. The relationship. Okay, are we together here, guys, with the stream order? Are we together? Let's understand. Let's talk about this first before we can go back to the diagram. I want us to understand this before we can go back to the diagram. Are we together? Are we together, guys? Are we together? Can you give me a thumbs up if you are together? Okay, Nolwande, what's the confusion now? What is confusing you? Nolwande, what is confusing you so that I can know how to help? Stream order is basically the arrangement. How do we get for the arrangement of streams in a drainage basin? Okay, okay. Can you see here? Can you see where my cursor is moving? Can you see where my cursor is moving here? We have got order 1 and 1. It gives you the next order, which is 2. That's how we got these 2 here. That's how we got these 2 here. So order 1 and 1 gave us stream order 2. Then here, order 1 and 1 gave us stream order 2 here as well. Okay? Are you following? Bit by bit. So this 1 here as well, order 1 here and order here gave us also stream order 2 here. Same applies, 1 and 1 gave us 2 here. I'm going where it starts, 1 and 1 gave us 2 here. So your 2 and 2 gives the next order, which is number 3. That is order 3 here. Okay? Then here, if you follow this line, you can see 2 and 2 is giving you 3. Then we have got 2 and 3, that is along this on the mainstream. 2 and 3, the order remains the higher number that we have, which is third order here. Then your third order that is coming from this side plus third order, it gives you the next higher number, which is order 4. That's how we get to order 4. Is it clear now? Nolwande, is it clear now? Nolwande, I'm waiting for your response. Thank you so much. Thank you so much. So let's go back to the diagram now. Let's go back to the question. Okay. So the question is saying now, okay, the question is saying 2.7 so that I can record. Okay, the question is now saying determine the stream order at X. Let's find out the stream order at X now. Let's find out the stream order at X. The stream order at X. Let's do it together. I want you to, okay, let's do it together. Which means we have to consider all this in order to for us to come up at this, to know the answer for the stream order at X. So it means here we have got what? I'll try to see if I can be able to do it. Let me see if I can able to do it with this. So here what we have 1. Here we have got 1. Here we have got 1. So 1 and 1 gives us 2 here. Then 2 and 1, which means here each one is 2. Here we have got 1 and 1. It gives us what? 2. Here we have got 2. Let me write it nicely. 2. Then here we have got 1 and 1. It gives us 2 here. Then you have got 1, which means here we have got what? Here we have got 2. So this 2 and 2, obviously here is going to give us what? 3. 2 and 3, here is going to be 3. Okay, it's going to be 3. Here what we have? 1 and 1. It gives us 2 here. 1 and 2, it gives us 2 here. 1 and 1, it gives us 2 here. 1 and 1, it gives us 2 here. Then we have got 1 and 2. We have got what? 2 here. 2 and 2, we have got what? 3 here. Already this 2 and 3 is giving us what? 3 here. Then here we have got 1 and 1. It gives us 2 here. And then we have got 1 and 1. It gives us 2 here. 2 and 2. We get what? 3. Then 3 and 3, it gives us 4 here. 4 and 3, which means here is the 4th order. That is our answer here. Is the 4th order. That is the stream order. 4th order. Okay. So it's the 4th order. Okay. Do we understand how I came up with the 4th order HX? Do you understand, guys, how I came up with the 4th order? Did you see how I was doing it? Can you confirm? Can you confirm? Did you see how I was doing it? Thank you so much. Thank you so much. Let's go back to the question now. So the question here, which means our answer here is 4th. That is the 4th order. Okay? 4th order. That is the question there, 4th order. Explain the relationship between stream order and drainage density. I've already said this. The higher, you remember when I said the higher the stream order, the higher the drainage density. Do you still remember? That is the relationship. So we are saying now the relationship is the higher the stream order, comma, the higher the drainage density. Okay, the lower the stream order, the lower the drainage density. Okay, are you following here, guys? For 2.3.6, are we together? Are we together for 2.3.6? I hope I'm not confusing you. The higher the stream order, the higher the drainage density. The lower the stream order, the lower the drainage density. Are you fine with 2.3.6? Give me a thumbs up if you are fine. Give me a thumbs up. Give me a thumbs up. Give me a thumbs up. Are we fine? Are we fine? Are we fine? Okay, sharp. So let's move on to 2.3.7. Let's go to 3.3.7. So we are saying now for 2.3.7, explain how the slope and permeability of the underlying rock influence drainage density in B. Remember, we have said that in B there is a higher drainage density. How did it influence the drainage density in B? So we are saying now the steeper, the gradient. Okay, the steeper the gradient, the steeper gradient, let me just say the steeper gradient, okay? The steeper gradient, okay, promotes a surface runoff. Okay, the steeper gradient promotes surface runoff, which means more streams flowing. Okay, more streams flowing. That's how it results in higher drainage density. Higher drainage density. Okay. Okay. Then second one is saying the permeability of the rock. Okay. So we are saying rocks with low permeability, or impermeable rocks promote surface runoff, hence resulting in more streams flowing. That is your high drainage density. Okay, high drainage density. Okay. Okay, guys, are we fine? Is it clear, guys? Is it clear? Is it clear now? Is it clear now? Is it clear? Can you confirm if it's clear, guys? Can you confirm? So that's how you answer this question. That's how you answer this question. Is it clear? Mostly when it comes to drainage density, the two processes that actually explains drainage density is your infiltration and surface runoff. Remember, when it comes to surface runoff, we are referring to more streams, because when you've got more surface runoff, it means it's also going to add the number of streams that are flowing. That's how it results in higher drainage density. So I would prefer more surface runoff than erosion. Talk more about surface runoff and what? Infiltration. Like your higher drainage density, there is more surface runoff as compared to infiltration. Your low drainage density, there is more infiltration as compared to surface runoff. Don't talk about erosion at this point. We want to see what is adding to the total length of streams flowing. What is adding to more streams flowing, which is part of our high drainage density, is because of surface runoff. There are more streams that are flowing. Of course, guys, I think this has taken us to the end, guys. Thank you so much. So tomorrow we don't have a live. We are going to have another one on Saturday. That is GIS, Geographical Information Systems. Please do not miss it. So on Saturday, tomorrow I'll take a break. I'll just rest, guys, tomorrow. I think I've been busy the whole week. From Monday we had a live, Tuesday, Wednesday, and even today. So tomorrow I'll take a break. I'll rest tomorrow. Then on Saturday. So Saturday, so let me just type here. Sorry. Saturday, we have geographical. We have GIS. Let me just say GIS. We have GIS. Okay. So we have got GIS. Okay. We have GIS on Saturday. So tomorrow, guys, I just want to rest. I've got YouTube, guys. I'm also streaming on YouTube now. I'm streaming on both YouTube and also on TikTok. So on Saturday, let's make a date, guys. We are going to do GIS in detail, Geographical Information Systems. I also want you to have, if it's possible, on Saturday, make sure you've got a copy of a map. You're supposed to have a map, because we are going to talk about everything that has to do with Geographical Information System. Make sure you've got a map, a topographical and an orthophoto map. Make sure for the Friday live, you've got a map, a topographical and an orthophoto map. Okay, that's what I want you to have on Friday. Okay, on Saturday, sorry, Saturday. So Saturday, GIS, then Monday, 8 o'clock, same time. Then on Monday, we are going to do map interpretation. Map interpretation on Monday. Then on Tuesday, map calculation. Then we are done with paper 1. I will inform you about paper 2 now, after that. So we'll be done with paper 1. So Saturday, GIS. Sunday, I'll rest, which means only this week I've only rested on Friday and Sunday. That's what those are the 2 days I'm going to rest. So Saturday, Geographical Information Systems. Monday, Sunday, we rest. Then on Monday, map interpretation. Make sure you've got a copy of a map. Even on Saturday as well, when you're doing GIS, make sure you've got a copy of a map, because you're going to talk about vector data, raster data, attribute data, you understand? So I want you to have the map so that you can know exactly what I'll be talking about. I don't want it to sound like Greek. So on Saturday, Geographical Information Systems in detail. Geographical Information Systems concept, your attribute, your buffering, data manipulation, data integration, standardization, querying, all those things. We are going to look at them. Remote sensing, what you call data layering, identifying the different layers on a map, all those things. We are going to look at them. Resolution, we are going to do that. We are also going to mention the area of photographs, that is your vertical, your oblique, horizontal. How do you see that a map is an area, okay, is a vertical or horizontal or oblique area, a photograph? You are going to look at all that. So please be prepared. Saturday is going to be something else. GIS, your Geographical Information System, same time, 8 o'clock to 10 o'clock. That's what we are going to do. And don't know if you have got any request when it comes to the live on Saturday. That is your GIS. Do you have any special request on areas what you want me to focus before we call it a night? Any special request for our Geographical Information System session on Saturday? GIS, any special request? Do you have any special requests for Saturday? Any special requests for Saturday? I can see you are fine. Okay. All right. Thank you, guys. Have a blessed evening. Thank you so much. I think this has taken us to the end of our session. Thank you so much, guys. Please, when you have time, please share my TikTok profile with your classmates. Go and subscribe as well on my YouTube. There is a link on my bio. Please just subscribing. You are not paying anything, guys. Just subscribe. I need as many subscribers as possible on my YouTube channel. Please just go and subscribe. You just click on the subscription button. You are not paying anything. Just to subscribe. It's like following on YouTube. Just to subscribe, please, can you go? I've got more than 50,000 followers here. Please, if all of you can go and subscribe on my YouTube channel, please, I really appreciate. I would really appreciate if you can do that. All of you, I think I've got about 666 people that are watching now. Please just go to my YouTube channel and hit the subscription button. You are not paying anything. It's just like following. I need more followers on my YouTube channel. Please just go and subscribe. Click the subscribe button on my YouTube. Thank you so much, guys. Have a blessed evening. Thank you so much. Thank you so much. It was nice hosting you. Please, tomorrow we don't have a live tomorrow. Tomorrow I'm going to rest because I've been busy the whole week. I have a live on Monday, Tuesday, Wednesday, and today Thursday. Okay, okay. Content on YouTube. I'm actually streaming on YouTube as well. So everything that you have on TikTok here is also on YouTube. Everything is there. I'll also do the same. Thank you so much, guys. Have a blessed evening. Thank you. Goodbye.